So you done then? So what I'm
Yes,
saying here that okay. So what is caustic soda? You know caustic soda? Caustic soda is a base, okay, which is a very strong base. We call it sodium hydroxide, okay. And sodium hydroxide is prepared. How sodium hydroxide is prepared? Uh, what we are going to study in the salts, okay. First of all, let me explain them. That in salts, we are going to discuss the caustic soda. Okay, there are 5 types of salts we are going to study, and preparation of the salts and the uses of salts we are going to discuss. Okay, so if I'm talking about the caustic soda is a strong base. It is a base, not a salt, first of all. But why we are studying this one in salts? Still, it is a base, just because it is prepared from a salt, which is sodium chloride. Okay, got it?
okay. Yes, sir.
So how it is prepared? How it is prepared? Let me explain. For examples, you take sodium chloride, NaCl, okay, and in a concentrated solution of sodium chloride, okay, which is concentrated means you keep on mixing sugar unless and until the situation come that no more salts can be added. Okay, so we take this concentrated solution, and B, the solution of sodium chloride in water is given a special name that is called brine. We call it brine. When we pass electricity to it, then it will give you NaOH. When you pass electricity to it, it will give you NaOH plus
Yes,
chlorine gas plus hydrogen gas. Plus chlorine gas plus
hydrogen gas.
hydrogen gas. So if I ask you that you have sodium NaOH, okay, sodium hydroxide, and this is a sodium hydroxide, and this is formed here. This is a chlorine gas, and this is a hydrogen gas. So if I ask you that chlorine gas, how chlorine gas is prepared, how hydrogen gas is prepared, so let me explain. That when we are having an electrolytic cell is a cell which is going to have an anode and a cathode. Okay, an anode and a cathode. Right? So when we have a positively charged rod here and a negatively charged rod here, and we are passing electricity to it. Okay, we are passing electricity to it, and this is the solution of NaCl. So we'll notice that in this solution we are going to have Na positive and Cl minus ion and H positive and OH minus ion. Got it?
Yes, sir.
So this Na and Na is good electron donator. You can see that Na is present at the top of the reactivity series. Okay, so we'll say that here that they are present at the top of the reactivity series. So it can donate the electrons. So if an element is present at the top of the reactivities, if it is just for losing the electron, so it will be last in accepting the electron. What I said, repeat and explain. Please explain me. What did I say?
Sorry, sir.
What did I say? Tell me. If
Na
I'm
is
saying yeah, is found at the top of the reactivity series. You see that potassium, after potassium we have Na. Okay, we have Na.
okay.
Now if I ask you that Na is present at the top of the reactivity series, on what basis it is present? On what
The
basis we have? Tendency to lose electrons. Tendency to lose electrons. So if Na is here to lose the electron first, we are place that one. Like for example, if a person is a good hater of we can say that some other things. Okay. So like for example, if A is a person and he is a boss of hating something, okay. Like we can say that like A is a person who hates watching movies. Okay, watching
okay.
movies. Just for example, I'm just explaining you. So can he be? Can he be? And B is a person who loves movies. B is a person who loves movies. Love. He is top. He is at the top in for loving the movies. Okay. So if I ask you that if A is at the top in watching movies, sorry, in hating movies, so can A be at the top of uh of loving movies also? No, no. Okay.
Okay.
So same thing happens here. If sodium is at the top in losing the electron, so it will not be at the top in gaining the electron. It will be at last in gaining the electron.
Okay.
Okay. Like for example, they are the two elements, like for example, sodium positive ions and H positive ions. So if I need to donate the electrons, so you see sodium is here and hydrogen is here. So sodium is good in donating, but it will be last in hitting, in accepting the electron. And hydrogen, for example, if I ask you that out of sodium and hydrogen, which will donate the electron first? Out of sodium and hydrogen, which will donate the electron first? Tell me.
Sodium.
Sodium will donate the electron first. Okay. So if I said that if sodium is ready to donate the electron first, then if I ask you that sodium and hydrogen, which will accept the electron, the hydrogen will accept the electron because it is late in donating, it is fast in donating, it is late in donating. So it will
Okay.
be first in accepting. It will be first in accepting. So what I'm saying here is that this is H. So H positive ion is there, so it will accept the 2H plus ion will goes and they will accept the electron and will form H2 gas. H2 gas. Got it? They will form H2 gas.
Yeah.
So what I'm saying here is that just a minute. Let me update the topic. So what I'm saying here that this will accept the electron first. Okay, this will not accept. So unless and until all the hydrogen ions will be there, they will keep on accepting the electron. So if there is hydrogen ions, if there is no hydrogen ion, then sodium will be given the preference. Okay, but if there is hydrogen ion, then it will be keep on accepting the electrons. You understood? So that's
Yes,
why
sir.
out of this Na positive, H plus ion from water will accept the electron and form hydrogen gas. Similarly, we have OH minus ions and Cl minus ion. So in donating the electron, we have Cl minus ion is at the first. Like for example, if I'm asking that zinc is more reactive or copper is more reactive, so you will say that zinc is more reactive in terms of donating the electron.
Yes,
Similarly, if I ask you that out of Cl and OH minus, which will donate the electron first, Cl will donate the electron first. Cl2, the two Cl ions will lose two of its electron, will form Cl2 and will get two electrons. Okay, and the donation of electron is done at cathode. At cathode, because cathode is negatively charged, it will donate the electron. It is electron, and at anode, the electron.
gain electron.
So anode means positively charged. Sorry. At anode is
Not positive.
electron. This is Cl will goes at negatively charged, so it will goes to negative positively charged. So anode Cl minus to the two Cl minus ion will go. They will donate the electron and will form chlorine gas. The chlorine gas is formed at anode. Okay, at anode. You understood?
Yes, sir.
And the H plus ions will goes the two electron will goes to will means at you know that it is positively charged. So this ion, since it is positively charged, so it will goes at cathode. Cathode is negatively charged, so they will go at cathode. So at cathode, which is electron donating nature, cathode is electron donating nature, so it will donate the two of its electron and form hydrogen gas. You understood?
Yes, sir.
Understood? So
Yes,
when
sir.
it form the hydrogen gas, so it will be like this. Okay.
Okay.
So now you see that Na is remaining and OH is remaining, so they will combine together and they will form NaOH. And since
Yes, sir.
in this process, the chlorine gas is formed. Chlorine gas is formed, and this base is called alkali. Water soluble base are called alkali. Alkali water soluble base. Soluble base is called alkali. Okay, it's called alkali. So since alkali means water soluble base is formed in this one, so this process is known as chloralkali process. Okay, chloralkali process. So note it down this one in the proper manner. Chloralkali process due to the formation of chlorine gas. And write down each and everything that at anode which gas is going to form, at cathode which gas is going to form. Wait fast.
Okay, done.
Okay, done. So do this one also.
Karida?
Yeah, what are you saying? You noted?
Yeah, I finished.
Yeah. So here I am explaining here that this is the sodium up to silver. We have this reactivity series because we have the metals reactivity series. Okay, but it will keep on going. After silver, we have F minus, then SO4 minus, then we have Cl minus. Then this reactivity series is based on donation of electron. And we have OH at the last, which is least in donating the electron. So Cl minus will donate the electron first as comparison to OH minus. Okay.
Okay.
So that's why at naught, the Cl minus will donate the electron first rather than the OH minus. Okay, do it. What would happen if we don't take the concentrated sodium chloride? So note it down this one also. If we took the dilute sodium chloride in the dilute solution instead of this one, then instead of chlorine gas, the hydrogen gas, hydrogen gas and oxygen gas will be formed. Okay. In simple, electrolysis of water will take place.
Sorry,
Sodium
sir.
hydroxide.
I didn't hear. I didn't understand.
Means if we have dilute solution, then we'll say that because of some reasons, okay, oxygen gas will be produced. Okay, if we took the dilute solution.
Only oxygen.
Yeah. And sodium hydroxide will form. Okay. So done.
I'm writing the last one.
Yeah. Yes, use and
Yes,
done.
sir. Yes, sir.
Okay. So let's look further. So why it is known as chloralkali process? Let me know. Why it is known as chloralkali process?
Due to its formation of a chlorine gas.
Yeah, simple, because chlorine gas is formed and the chlor for chlorine gas and alkali is a water soluble phase. Okay. So if I ask you that if for the physical properties, what are the physical properties of this sodium chloride? So that is very simple, that it is a translucent. Have you seen the sodium hydroxide ever? Have you ever seen the sodium hydroxide? It is just sodium hydroxide crystals. Have you seen sodium hydroxide crystals? No.
Sorry, sir, I didn't get
Let me
you.
show you. Yeah, I'm showing. Have you ever seen sodium caustic soda? Caustic
I
soda.
know, no, sir.
No, caustic
No,
soda
sir.
is a very corrosive base. It is very corrosive base. It is just similar to that we called means simply it is similar to that big sugar crystals. Okay, like we usually got when we went to some restaurant. Okay, so after having a lunch or dinner there, we have some crystals of sugar, bigger crystal. We called it misri in Hindi. Okay.
Yes, sir, I know.
Let me show you here. Yeah, this is the caustic soda. Okay, it is just somewhat similar to that. Okay, like you can see here, this is the caustic soda, bigger crystal of sugar. This is sodium hydroxide, and it is actually hygroscopic in nature now, because yeah, now you see nowadays we have moisture in the air. Okay, so it will absorb the uh, uh,
Yes, sir.
moisture and will become sticky, some slippery type. Okay, so because it is very means we can say that it absorbs the moisture from there. Okay, so this is like
Okay.
this one. It is white translucent, not we can say that not opaque, allow light some amount, but it is translucent type of crystals. So just write down its features, that it is translucent, melting point is 591 Kelvin. Readily soluble in water means it readily means not it spontaneously, it take time. Okay, like the sugar crystals take time. Deliquescent means absorb moisture from the deliquescent means
From the
absorb
air.
moisture, absorb moisture from the air. Okay, make it done.
So should I write the uses?
You saying?
Should I write the uses?
Yeah, you have tried to use this also.
Okay.
When it is kept in open air for a long time, then we simply say that it becomes okay, noted. Sodium carbonate.
So what is that? Purification of
You say clarification. It is
purification
used
of
in purification of bauxite or bauxite, bauxite ore.
What is bauxite?
Bauxite is an ore of aluminum. Ore is something from which we extract the metal. For example,
Then rock.
we can say that aluminum is present in different compounds, but the compounds or the extraction that we get from the earth crust, from which we extract the aluminum, that is called bauxite ore. That is a mixture of Al2O3, Al2O3 dot 2H2O. This is bauxite, ore of aluminum bauxite.
Okay.
Okay. Done.
Yes, sir.
Next we should be moving towards the bleaching powder. Okay. Bleaching powder is we can say that it is another compound or another salt which is prepared by passing chlorine gas to the slake lime. Okay. So slake lime is actually, let me explain you what is slake lime first. Slake lime, when we have calcium hydroxide, okay, calcium hydroxide, and this calcium hydroxide, okay, this like for example, let me show you what is difference between the slag lime and lime water. They both have same formula. Slag lime, slag lime, and lime water, they both have same formula. But actually, if I talk about this slag lime is something dry, okay, dry sodium hydroxide. Okay,
Okay,
like you
sir.
have milk, like you can assume that you have milk, and the when milk get hot, it has a means malai. You understood malai?
Ah, yes, sir.
Or the okay. So
That's
that
fine.
is like the slag lime. Okay. So the precipitate of this one. So let me show you here also, so that you can understand it much betterly. Okay. So you can understand it. Those this questions comes. So you can understand it much betterly when you have. So here it is. Yeah. So like you have this one.
Lime water is simply an aqueous solution of calcium hydroxide. This reaction is in fact a part of a much bigger cycle called the limestone cycle. Limestone is a type of sedimentary rock with a high percentage of calcium carbonate. In this lesson, we will learn about how limestone is formed. Some uses have percentage of calcium.
Okay.
Limestone can be thermally decomposed in a rotary kiln.
So when you have limestone, okay, and you heat it, keep it heating it, so it will release the carbon dioxide and form calcium oxide. Okay. Are you getting me?
Yes, sir. But
So it will form calcium oxide. Like you have limestone, like you have calcium carbonate, CaCO3. Okay, and you heat it. So when you heat it, it will become calcium oxide and release carbon dioxide. Okay, so this is calcium oxide. Now this calcium oxide, when passed through water, it will form calcium hydroxide. Calcium hydroxide. Then large amount of heat is being released. Okay, so when we make this one, there is some dry, like when we make this one, There is something like which is going to be like very watery, and another thing is very dense. So dense is called slag lime, and the very watery state is called lime water. Okay, so lime
Yes,
water. So let me show you here. Okay,
to give quicklime and carbon dioxide. The chemical name for quicklime is calcium oxide. A rotary kiln is a kiln that is able to rotate as the reaction proceeds. This helps to ensure complete thermal decomposition of the entire limestone sample. As this process requires heat, it is an endothermic reaction. The reaction of quicklime with water produces slaked lime. The chemical name for slaked lime is calcium hydroxide. This is a highly exothermic reaction, and the industrial process is called slaking. Slaked lime can be dissolved in water to form lime water. Since it is only slightly soluble in water, a large amount of water is required. Lime water is simply an aqueous solution of calcium hydroxide. As you can see, we have almost completed.
now you understood the concept.
yes, sir.
So let's come back to this. Okay, so now we have this lime water, and this lime water if I'm talking about this lime water. Okay, so this lime water is actually having uh, calcium hydroxide. But if you have this slaked lime, which is dry, get dry. So when you pass chlorine gas to it, it will form calcium oxychloride, CaOCl2. That is called bleaching powder. Bleaching powder. Got it?
Yes,
Plus
sir.
water. Water. This is the preparation of bleaching powder, that when we passed chlorine gas to the calcium hydroxide, it become okay. That is called calcium hydroxide. And it is calcium hydroxide. When chlorine gas is passed, it forms bleaching powder, which is calcium oxychloride or calcium hypochlorite. Sometimes the question may be also asked in the examinations. Okay, related to the this one, that what is the chemical name of bleaching powder? The bleaching powder chemical name is calcium oxychloride, CaOCl2, or calcium hypochlorite. You understand?
Yes, sir.
So note it down, and just a minute. So, and the process by which we prepare the bleaching powder is known as Hazen-Claver process. Okay. So
Sorry,
note
sir,
it down.
what is the name?
Hazen-Claver process. Hazen-Claver process.
Mhm.
Yes, note it down.
Okay.
Noted.
No, sir. One second. Yes, sir. Finished.
Properties. Like you see that this is a very important uses and properties of this one. That it is going to have very strong smell of chlorine. Okay, because chlorine gas is passed through it, but it is not chemically bonded. Okay, it is bonded, but it when it get a chance to leave, when the chlorine get a chance to leave, so it can easily leave. So chlorine, it is a compound which has a very strong smell of chlorine. So if the question come a compound X, okay, which has a very strong smell of chlorine. So we have studied this one in our syllabus that bleaching powder is that compound that is going to have. So you must remember this one. Okay,
Okay.
write down this one. Done.
No, sir.
Right up to here only.
Okay.
Okay, so when we kept the bleaching powder in open here, it react with the atmospheric carbon dioxide and form calcium carbonate. Okay, and chlorine gas is eliminated. And when there is no chlorine, it will not be of any use. So if the question comes that why we should keep the chlorine so bleaching powder in airtight container, just because if we don't cap it in a airtight container, it will start reacting with the atmospheric carbon dioxide.
Okay. Okay, sir. Done.
Yeah.
Yes, sir.
Uses of bleaching powder. It is strong disinfectant and used for clean jars of water. It is chiefly used for bleaching cottons and linen textile. Yeah.
No, sir.
So the question comes, yeah, they means there can be two things that can be you need to remember for the bleaching powder, that it has a strong smell of chlorine. Sometimes question comes and compound X, which has a very strong smell of chlorine. So you must remember that it is bleaching powder. And second thing is that if they ask you that a compound X which is used for killing germs or disinfectant, which is used as disinfectant. So you must remember that if we are talking about the bleaching powder, okay?
Yes, sir. Okay, sir. Done.
Done?
Yes, sir.
Next. Here we have a question. Note this question and answer this question, please. Next slide.
Okay, sir. Done.
Right? So what's the answer? What's the answer here?
Sir, I understood the question.
So just read the question and answer this question, because on the basis of the two salt that we have studied, this is the question for it.
Okay, sir. All right. Sir, I didn't understand the question.
You understand? A
Yes,
compound X on electrolysis in an aqueous solution produces a strong smell. Why? So we have NaOH.
so that anyways, okay.
Okay, strong base. Okay, now you're saying compound X on electrolysis. So which salts we have studied? Which on
Salt, sir.
electrolysis?
Caustic soda.
NaCl. NaCl when on electrolysis give a strong base X and the two gases. Okay, so this we have studied. The electrolysis only we have studied now.
Okay.
Compound that is prepared by electrolysis. So a compound X on electrolysis in aqueous solution produce a strong base. So we have NaCl when it is in aqueous solution. On electrolysis means on passing electricity, it will gives you NaOH plus chlorine gas plus hydrogen gas. Okay, this is a strong base. Y. Okay, this is a compound X and two gases A and B. Okay, B is used for the bleaching powder. So tell me that which gas is used for making bleaching powder? Part of this. Which one is A or B?
Sorry.
Which one is A and B gas in this one, according to the question? Two gases. One is A, another is B. Tell me which one is A, which one is B.
Sir, chlorine.
Chlorine is A or B?
And the third is A, B is sir, B.
Chlorine is B. So it is B. Because it is saying B is used for bleaching powder, so this is only. Okay.
Okay.
Understood?
Yes, sir.
Next, we shall be moving towards the let's write the third side. That is plaster of Paris. Okay, plaster of Paris. So what is plaster of Paris? Plaster of Paris is actually calcium sulfate hemihydrate CaSO4 dot half H2. So how it is prepared? When controlled heating is done, when we have gypsum, it's called calcium sulfate dot 2H2. Okay.
Okay.
Then so when we have calcium sulfate dot 2H2, and this is called gypsum. That is called gypsum. So when we have gypsum and we heat it, it will gives you CaSO4 dot half H2. Okay, and here it should be that there should be when we are heating gypsum. Okay, we control heating should be done. Control heating should be done. Control heating means
Control. The heat should be limited.
yeah, it should be at 100 degrees Celsius according to NCRT or 373 Kelvin.
Okay.
Kelvin.
Okay.
So when control heating is done, it will lose 1.5 molecule of it. 1.5 molecule of it. 3/2, you can write 3/2, or you can write 1 pass 1/2 molecule of it. And this is called gypsum. Sorry, this is called POP, plaster of Paris. But what happens if uncontrolled heating is done? Then the whole water molecules of means two, means the whole. And if we do the uncontrolled heating during the preparation of plaster of Paris, which is dot to H2. So when uncontrolled heating is done, then it will give you CaSO4. Okay, and the two water molecule will rise. Okay, so do it fast.
Okay. So should I write this?
You have to write. You have to write. Just a minute. Just a minute. Just a minute. So you have to write it. Start writing from here. Just a minute. Write it. POP. That is called CaSO4 dot half H2. It is calcium sulfate hemihydrate. HEMI hemi hydrate. Okay. Note it down.
So what is water of crystalline here? Sir, your voice is not clear.
What I'm saying here is that if I'm talking about the plaster of Paris, so that is calcium sulfate hemihydrate. Okay.
Okay.
And you have to write the preparation, POP, preparation of plaster of Paris. Yeah, POP preparation you can write, or you can write preparation of plaster of Paris. So it can be prepared when we have calcium sulfate dot 2H2, and then you start heating it according to it, it will gives you this one. Okay.
Okay.
Noted.
Sir, what is the water of crystalline?
Water crystalline is actually the loosely water attached molecules with the with some compound. Like for example, you have calcium sulfate dot 2H2O. So this is water crystalline of this one. Like we have copper sulfate dot 5H2O. So we called it loosely attached water molecules.
Okay.
Got it?
Yes. So can you change to the other page?
Yeah, yeah. Loosely attached molecule per unit formula of the compound. But actual temperature, like I have written two types of temperature here, 120 degrees Celsius and 393 Kelvin, because it is actual written in many books. But in NCRT, it is written 100 degrees. So you have to write 100 degrees. Okay, we have to
Okay.
follow the rules of 100. Have you seen the plaster of Paris ever?
Yes, sir.
It is in your home also.
Yes, sir.
It is in your homes also. It might be in your home
Yes,
for
sir.
sure. Okay.
Okay, sir. Hearing it.
So here the question comes that what happens if uncontrolled eating is done during the formation of POP? If uncontrolled eating is done during the formation of POP, then whole water of crystalline will get evaporated, resulting in the formation of anhydrous. Anhydrous means without water. Anhydrous calcium sulfate, which we called it dead burnt plaster. Okay, this is question is very important that is going to come through related to the POP. So do this.
Okay.
Done. So what would happen if uncontrolled eating is done?
The water of crystalline gypsum will evaporate, resulting in anhydrous CaSO4, and it will form dead burnt plaster. Okay, sir.
So, there one more question comes here. Okay, that what would happen if POP is kept in open air? Like you see that when we keep NaOH in open air, it will become sodium carbonate. When we keep bleaching powder in open air, it will become calcium carbonate. So they were reacting with atmospheric carbon dioxide. But here, if we keep the POP for a long time, then it will absorb the moisture again. The half molecule that it has loosened, it will absorb that one and become very hard. Like you see that during the time when our hand got fractured, so we have done the plaster over it, but during the time it is not okay. But when we keep it, so it will keep on absorbing the moisture from the atmosphere and will become very hard and dense substance with called dead burn plaster. Okay,
Okay,
gypsum.
sir.
Okay, so note it down that it will
Okay.
absorb the moisture from the atmosphere and will again turn to gypsum, which is very hard and of no use.
Yes, sir.
Okay. So Nabil, just write down the uses of this book. Then it will be okay. Uses of decorative, that it is using decorative items, it is used for fixing fractured bones, it is used for making toys. After you've done this, you can leave.
Hello. Hello.
Sir, I'm done. Sir,
Okay, sorry, I went to the washroom. Okay.
okay. Okay, sir.
Okay. So that's all for today. You can leave.
Okay. Thank you, sir.
Yes, Nabil, how are you? Is I'm audible to you?
Yes, sir.
So Nabil, in the previous class, what we are studying?
Um,
We were studying about the chemical properties of metals and some bases also. Bases chemical properties. Metals reaction with base. Okay. So I'm just going to give you a questions over here and then you have to write the answer to this question. Just Uh, yes, Nabi, if I ask you that, have you learned the valencies of those compounds? That means valency chart with the help of valency chart. Have you done each and everything
Which valency chart?
that I have given you?
Wait, the valency chart for like all of those ion elements, right?
Yes,
Even polyatomic.
yes.
Yes, I did.
Okay, just let me check how many of you of this you have done.